So in the previous segment, as you know, we have discussed about the significant figures. Now it's the time to see more topics regarding the same mathematical operations. Now the first topic is rounding off of uncertain digits, following which we will study about certain numericals. So the first topic is rounding off of the uncertain digit. The rule says if the insignificant digit to be dropped is more than 5, the preceding digit is raised by 1. This can be clearly understood by a simple example. So I'm taking an example. So let's suppose I have a number which is 3.774. Now let's suppose I'm circling this number 7. This 7 needs to be dropped. Now tell me what is going to happen. Let's read the rule again. The digit to be dropped if it is more than 5. So tell me the number we need to drop is 7. Is it greater than 5? Yes. So then the preceding digit, that means the digit before this digit which is to be dropped, the preceding digit is raised by 1. That means if I need to drop this 7, the answer will be 3.8. I hope this is very clear to you. So whenever you are actually dropping a digit, just check that digit is actually greater than 5 or not. If it is greater than 5, then add 1 to the preceding digit. Now, rule number 2. If the insignificant digit to be dropped is less than 5, the preceding digit is left unchanged. For example, 3.74. So let's suppose I'm circling this 4. This needs to be dropped. What is going to happen? Since this is number 4 which is less than 5, the preceding digit will remain unchanged and you can directly drop it. So this number will become 3.7. I hope this is clear to you. Now what will happen? We have studied that whenever the digit to be dropped is greater than 5, we can add 1 to the preceding digit. And whenever the digit to be dropped is less than 5, we can leave the preceding digit unchanged. But what is going to happen if the insignificant digit to be dropped is 5 itself? The preceding digit is raised by 1 if it is odd and it is left unchanged if it is even. So let's take two examples. Example number 1 is 3.745 and example number 2 is 3.735. Let's suppose I need to drop this 5 in both the numbers. So what is going to happen? These two are two different cases. Now when I am dropping this number 5, I need to check the preceding digit. Preceding digit is 4. That means it's an even number. So whenever it is even number, it is left unchanged. So this will reduce to 3.74. I hope this is clear. Now what will happen over here? When I need to drop 5, the preceding digit I need to check and this number is actually odd. So in order to make this even, this will become 3.7. So that's how this kind of rounding off happens in mathematical operations. I hope the idea of rounding off is very clear to you. Now let's try to analyze all the concepts which we have learned regarding the significant figures and the rounding off of uncertain digits in some practical questions. So the question number 1 says, let's suppose mass of an object is 10.02 plus minus 0.01 gram. Velocity is 5.5 plus minus 0.1 meter per second. What we need to find out? Find out momentum of the object within the error limits. So let's try to solve this question. Now the first thing we know that momentum is labeled by P and it is actually the product of mass and velocity. So this will come out to be, mass is given in grams, so this is 10.02 multiplied with 5.5 and this will give me 55.11 gram meter per second. So we have the real momentum. Now what is going to happen? If I want to write down an error equation for this, then tell me delta P by P should be equal to delta M by M plus delta V by V. And if I want to multiply 100 on both sides, this is delta P by P into 100 is equal to delta M by M into 100 plus delta V by V into 100. So the percentage change in momentum is equal to the percentage change in mass plus percentage change in velocity. So let's try to write it down separately. Now tell me what is delta m by m. Delta m is actually 0.01 divided by m is 10.02. So I can write it down. This is 0.01 divided by 10.02, then multiplied with 100. This is the first number that we have. Then plus, we have the next number as 0.1 divided by 5.5 into 100. And if I solve it up, this will come out to be 0.099, and this is plus. This will give me 1.8, and if I solve it up, this number would approximately be 1.9. So this is coming out to be delta P by P into 100. Now from here I can find out the change in momentum simply. So delta P would simply be P multiplied with 1.9 divided by 100. Now P value we have calculated. Now the answer that we have written over here is actually up to 4 significant figures. But tell me, here the number that I have multiplied has only 2 significant figures. The mass is being labeled as 4 significant figures. So the answer should be reported as the least number of significant figures. So this momentum should simply be written as 55 gram meter per second. So I can use this value over here. So this is 55 into 1.9 divided by 100, and if you solve it up, this delta P will come out to be approximately 1.04 gram meter per second. So the final answer of momentum can be written in this manner. So this is P plus minus delta P. So this is 55 plus minus 1.04 gram meter per second. But tell me, if you are going to take the error limits, the mean value is up to 2 significant figures. But if I take the error limit, the answer will come out to be in 4 significant figures. So in order to maintain that consistency, I need to write this as 55 plus minus 1 gram meter per second. So this should be the error limits of the momentum. So this is the final answer we were searching for. So that's how the questions can be solved in this manner. So let's see more example based on that. Now the question number 1 says, the number of significant figures in the number 0.005680 into 10 to the power minus 3. Now this number has been written in the exponent form. So you must remember that this is not going to contribute to the significant figures, but you must remember that in a number which is less than 1, the zeros which are on the left side of the first non-zero digits are considered insignificant. So there are 4 significant figures which are present in this question. Option number 1 is the correct or the right answer for this question. So let's move to the next question. Next question says, what is the number of significant figures in 3.50 plus 450 in the bracket multiplied with 10 to the power 5? Now, let's try to sum this number up. This would simply be 3.50 plus 450 multiplied with 10 to the power 5. This will, on calculation, will give me 453.50 multiplied with 10 to the power 5. Now tell me, what is the rule for addition? Whenever we are actually adding the numbers, the number of decimal places that we need to take in the answer should be as much in the least of the original numbers involved. So here in this I have 2 decimal places, in this I have 0 decimal place. So the least is 0. So the answer should be kept at only this decimal needs to be dropped. So this answer would be 453. But the most important thing, you are actually dropping this 5. So you need to check this preceding digit and it is actually odd. So that's why you cannot take this. You need to take a number that is 454 into 10 to the power 5. And in this I have 3 significant digits as the answer. So option number 2 is showing 3 number of significant digit as the correct or right answer for this question. So let's move to the next question. Next question says, round off the following number up to 3 significant figures. So let's see each part one by one. We have the first as 2.520. So this is the first significant digit, this is second, this is third. We need to drop this now. Since it is a number 0, I can simply drop it and this will reduce to 2.52. I hope this is clear. So the part 2 of the question. Part 2 says 4.645. Now this is the first significant digit, this is the second, this is the third. That means I need to drop this 5. This I need to drop. Now this number is 5. I need to check the preceding digit is odd or even. The number is 4, so it's even, so it should remain unchanged. So on dropping, this will come out to be 4.64. I hope the method is very clear to you. So let's move on to the next question. The voltage across a lamp is 6.82 volt when the current passing through it is 4.1 ampere. Find the power consumed to appropriate significant figures. Now that's a very easy question. We must know that power consumed is simply equal to product of voltage and current. So simply power is equal to 6.82 multiplied with 4.1. Now if you multiply this number up, this number will come out to be 27.962 watt. But tell me, the answer should be specific as per the rules of significant figures. The first number that you are taking as having 3 significant figures, this number is having 2 significant figures. So how many significant figures that you need to take or carry in your answer? Obviously the least, that is 2. So in this manner I need to take up till this, but I need to drop this 9. And whenever I am dropping a number which is greater than 5, I need to add 1 to the preceding digit, and that's why the power is 28 watt. And this is the answer we were actually searching for. So that's all in the segment. In the next segment, we are going to introduce a very fresh topic of dimension of the physical quantities and the importance of dimensional analysis.